Hello, today we are going to discuss about IPv4, or in this we will learn about what is IPv4 address and its address type, and how to define or how to represent the IPv4 addresses, and then IPv4 header or a packet format, and next is network address translation NAT. So let's first discuss about what is IPv4. So IPv4 is the Internet Protocol version 4, or it is a fourth version of the IP addresses. So the IPv4 is a connectionless protocol which is used in packet-switched networks such as Internet. So the devices in Internet have the IPv4 address so that it can be identified in the network. So it provides the logical connection between network devices by providing identification to each devices. And IPv4 is designed and specified in IETF Internet Engineering Task Force publication RFC 791. So these are the IPv4 addresses are the fourth version of the IP address. Next is the address type of IPv4. The address space is a total number of addresses used by the protocol. So the IPv4, how much address space is used by the IPv4. So IPv4 is a 32-bit address, which means it consists of 2 raised to power 32 address space, that is 4 billion address spaces. The example of the IPv4 address is 117.149.29.2 is an IPv4 address. So theoretically, more than 4 billion devices can be connected to the internet, but due to some imposed restrictions, like some IP addresses are reserved for some special purposes, so the actual number is much less than 4 billion. The next is notation of the IPv4. How we can represent the IPv4 addresses. So it is represented in two-way binary notation, and the next is dotted decimal notation. So in binary notation, the IPv4 is 32-bit address. So each it is represented in 4 octet, and each octet have the 8 bits, as the IP address 172.16.150.12 is shown in the example. It shows the binary notation of this IP address in 0-1 form. The next is dotted decimal notation. IPv4 address are written in decimal notation to make it more compact and easy to read. So the dotted notation is 172.16.150.12. This is the decimal notation of the IPv4 address, and its range lies between 0 to 255. The next is the IPv4 header or IPv4 packet format. So it is of 32-bit long, and it contains 14 fields. So let's discuss about these fields in detail. As the IPv4 header consists of 14 fields, but out of which only 13 are used. So the first field is version field. The first header field is an IP address of 4-bit long, and it indicates the version of the internet header or the internet address. So this 4-bit is set to binary 0100 for IPv4 and 0110 for IPv6 IP address. Next is header length. It is also known as internet header length, and this is the second field. It is of 4-bit, and it tells the number of 32-bit words in the header, and the minimum value for this field is 5. The next is type of service, that is TOS. It is also known as differentiated service code point. It carries the information about the quality of the service provided by the IP addresses. So as with the development of new technologies that require real-time data streaming, example is VoIP, voice over IP. Here we are using the TOS service type of service. Next field is total length. This is of 16-bit, and it defines the size or the entire datagram including header and data. So the minimum length of this datagram is 20 bytes and maximum is 65,535 bytes. Next is identifier. The identification field is used for uniquely identifying fragment of an original IP address, as it adds the sequence number to the fragments of the IP addresses. The next is flag. Flag is the control bits. So a 3-bit field is used to control and identify fragments. So these are bit 0, which are reserved, and bit 1 used for don't fragment, and bit 2 is used for more fragments. Next is fragment offset. So the fragment offset field is of 13-bit long, and it specifies the offset of a particular fragment. Next is protocol. This field defines the protocol which is used by the IP datagrams. Next is header checksum field. It is a 16-bit and it is used for error checking of the header. It detect the error and correct the error of the header field. Next is time to live, TTL. It is of 8-bit field and it is used to indicate the maximum time for which a datagram is allowed to remain in the internet system. So the maximum datagram lifetime or a hop in the range lies between 0 to 255. So the intention is to cause undeliverable datagram to be discarded in the network. The next is source address. This address indicates the IP address of the source of the packet. And next is destination address. This field indicates the IP address of the receiver of the packet. The last field is option field. This is an optional field reserved for the future use. So the next is NAT, that is network address translation. So NAT stands for network address translation or the network address translator. NAT is used to virtualize the IP addresses. So the network address translation is the process where a network device like firewalls assign a public address to a computer inside a private network. So a computer which are in private networks are assigned one public address by which they are recognized in the internet. It is done by the NAT, network address translation. So this help in improving security and decrease the need of large number of IP address in the organization. Or NAT is a method of free mapping one IP address space into another by modifying the network address information in IP datagram packet header. The next is in NAT, the private address range is used like for a class A, the range is 10.0.0.0 to 10.255.255.255, and for class B, the range is 172.16.0.0 to 172.31.255.255, and for class C, the range is 192.168.0.0 to 192.168.255.255, where the NAT technique works well for computer that only have to access resources inside the network or inside the private network. For example, if a host or a client want to access file server and printers. Thus, using private address routers inside the private network can route traffic between the private addresses with no trouble. And if a host or client wants to access resources from the outside network or from the internet, then the host must contain a public IP address. So in this way, the NAT or a network address translation works. So this diagram shows how the network address translation works. As these computers have the IP addresses and the private IP address, that is 10.0.0.1, and the public IP address is given by the NAT router is 145.12.131.7. So it is identified by its public address in the internet. The outer devices doesn't know it about its private IP addresses. So by using this NAT, the private addresses are in secure way. So in this way we are use the NAT. So this is all about IPv4. Thank you.